Hi again. We are still talking about TCP protocol, but now we are at the reliable data transfer, or basically we're going to show some examples of the transmission scenario in TCP. Okay, so before that, we're going to explain the event data both at sender and at receiver when it's going to send data at the sender and then when it's receiving data at the receiver side. Okay, so if we are taking the simplified version of TCP event at sender, first the sender will create segment with sequence number. Okay, as we already explained before, sequence number is the first byte of the segment. Okay, start timer if not already running. The timer is used to measure the timeout. So think of the timer as the oldest unhacked segment. If the timeout is reached, then we have the timeout interval. Okay. Now, when the sender get the timeout event, it means that it does not receive, it has not received the ACK from the receiver, so it has to retransmit the segment that's causing the timeout, and then it will restart the timer. Okay, now if the ACK is received before the timeout, okay, so there are different conditions. If the ACK acknowledges the previously unACK segments, okay, it will update what is known to be ACK. Okay, and start the timer if there are still unACK segments. So meaning that, as we said before, the TCP supports the pipelining. So basically, it can send multiple segments before receiving the acknowledgements. So if there are still some acknowledgements expected to be received, then the timer will be started again. Okay, now at the receiving side, there are four events basically in simple. Okay, so the first one is this is the ideal case, arrival of in order segment with the expected sequence number. So basically all data is up to expected sequence number or the ACK. So this means that the data until now is already received with the correct sequence numbers, with the correct order. So in this case, the receiver will delay the ACK, so waiting until 500 milliseconds for the next segment to be received. If there is no more segment after 500 milliseconds, then it will send the acknowledgement. Okay, the second case is the arrival of in-order segment with expected sequence number, and one other segment has ACK pending. So the difference with the first case is that there is one pending acknowledgements for the second case. In this case, already all the segments already have the acknowledgements. Okay, so in this case, the receiver will send immediately single cumulative ACKs, ACKing both in order segments. So basically, let's say I think we can. It is best to continue the explanation from the first case. So let's say after before the 500 millisecond time, there arrives the next segment at the receiver. So the receiver will send immediately ACK, okay, only giving the ACK number of the latest segment received by the receiver. So it's not going to send two ACKs for the two segments received by the receiver, but it only sends one acknowledgement with the number of the last segment received by the receiver. Okay, now the third one, this is when there is a loss, packet loss or the segment loss. So basically, the receiver receives out of order segment higher than expected sequence number. So basically, there is a gap detected. So let's say it receives a segment that is higher than the expected segment. So for example, it expects a segment number 100, but it receives segment number 120. So basically, there is a loss of previous segments. Okay, it does not receive the segment with the lower sequence number. So immediately the receiver will send duplicate X. So what is duplicate X? Because it still expects to receive the segment with the lower sequence number. Okay, it means for the sender is that the the segment with this duplicate X is missing or is lost. Okay, now let's say after it receives the segment that is out of order. Let's say it receives a segment that partially or completely fills the gap. So for example, this is the segment received, it's number 100. Okay, so it expects to receive number, let's say 110, but it eventually it receives 100, let's say 30. Okay, so there is either one or two segments missing in between. Okay, so if it receives a segment partially or completely fills the gap, let's say it receives the segment number 110. So what happens is it will immediately send acknowledgements, okay, that provided that segment starts at lower end of gap. So basically it starts to send acknowledgement with the last the next expected segment to be received by the receiver. Either this one, let's say 120, or if it fills the gap completely, then it will send the X with the next segment. So let's say 120, 140. Okay, now let's use an example to be more clear. So this is the lost X scenario. Let's say host A sends a segment with sequence number 92 with 8 bytes of data. Host B received the segment, but then the acknowledgement sent by B lost. Okay, get lost. And after the timeout, host A doesn't receive any acknowledgement from B, so it assumes that the sequence sent by host A is lost. Okay, so host A has to retransmit the same segment to host B. Okay, after the timeout. Okay, so since everything is alright, so host B sends another acknowledgement to host A. Okay, so this is the just general let's say retransmission because of the lost acknowledgements. Okay, now this is for the case of premature timeout. Okay, so basically now host A sends two segments to host B. Both segments arrive at host B, but then it arrives after the timeout. So that's why it is called the premature timeout. Okay, so what happens after the timeout? Host A will send another, the segment. So it assumes after the timeout, since host A doesn't receive the acknowledgement from B for the both segments, it assumes that both segments has lost. It sends again with the one segment. So why it sends only one we'll get explanation after we talk about the congestion control. Okay, but for now, let's say it starts from one. Okay, so it starts to send one segment starting from 92 because it's still, the segment that is expected by host B is starting from 92. Okay, now since host B already received both segments, okay, so it can just send acknowledgement number 120. Okay, the acknowledgement number of this host B is not 100 but 120. Why? Because now host B already has the first segment and second segment, and the next expected sequence number by host B is 120. So this is called the cumulative X. Now again, we have the case of cumulative X, but we have a bit different cases from the previous one. So we have the host A sends two segments. Again, the both segments sent by host A have been received by host B. Host B sends two acts for the both segments, but then the first act is lost in the way to reach host A. But then host A received only the second segment, the second act. Okay, so having received the segment, the act number 120, host A knows that actually host B already receives both segments, the 92 with 8 bytes length and the second segment with sequence number 120 bytes of data length. So in the next transmission, host A can just send the next segment with the sequence number 120 and whatever the number of bytes has. Okay, so now, okay, so in the next, the last three examples, scenarios, host A only sends the or only do the transmissions when there is timeout event. Okay, so there is also fast retransmission or fast retransmit. This means that host A can immediately send retransmission before the timeout. So how this happens? Okay, so basically it is host A detects multiple duplicate acts when host A sends several segments to host B. So for example, like host A sends 5 segments to host B. This is the pipelining. Okay, so for example, like this is 92 with 8 bytes of data, 100 with 20 bytes. Okay, if we continue along this in the next segment, we have 120, for example, with 20 bytes of data, and then 140 with 20, 160 with 20 bytes long. Okay, now the first segment arrives, it gives the act 100, but then the next segment is lost. So the next three segments, the last three segments, it will have the acknowledgement numbers 100. Okay, it means that host B still expects to receive sequence number 100 from host A. So having received three duplicate acts, so 3 duplicate acts is excluding the acts that is originally from the first segment that is expecting 100 sequence number of hundreds, but in the next one, the next 3 duplicate acts, then immediately host A knows that sequence number 100 is lost, so it sends immediately sequence number 100 to host B. Now let's say if we continue along this from the host B, so what will be the act number of when the host B sends the act from to host A? So the act number will be, since it already has all the packets received, all the segments received, then the act will be 180. Alright, so this is called the fast retransmit because host A doesn't have to wait for the timeout to be reached. When it detects there is a triple duplicate acts, it will immediately send retransmission, or it immediately retransmits the lost segments. Okay, so I think that's it for the example of the retransmission scenario in TCP reliable data transfers. We'll be discussing about the flow control in the next video. So see you again in the next video.